square root property and completing the square. Let's first talk about the square root property. If I give you this quadratic equation, this degree 2 equation, x squared is equal to c, and I asked you to solve for x, and we assume that c is some positive real number, then we can solve this by factoring the way we've been solving quadratic equations. Let's first set this equal to 0. So I have x squared minus c is equal to 0, and if I consider that c is the square of the square root of c, then I can view this as the difference of two perfect squares. Remember, the squaring of a square root cancels the square root out, and all you're left with is c. So this equation is definitely equivalent to the previous. And now I can use factoring to solve this. A difference of two squares like this factors as x plus root c and x minus root c. Setting each factor equal to 0 and solving gives us two solutions. One is negative root c and the other one is positive root c. So the square root property basically says if you have an equation of the form x squared is equal to c, notice that the squared expression is isolated, right? It's on this side of the equation all by itself. Then that implies that x is either equal to positive root c or x is equal to negative root c. You can use double sign notation here to just say x is equal to plus or minus root c. Here in this first example, we have x squared minus 75 is equal to 0. Now, you know, in previous lessons, in previous studies in algebra, we could solve this easily by factoring if this were a difference of two squares. However, 75 is not a perfect square, so that won't work for me. So what I do is I use the square root property by isolating the squared expression first. I add 75 to the right-hand side. And now that the squared expression is isolated, I can now take the square root of both sides. This is the square root property. So the left-hand side is just x, and we have, remember there's two solutions, plus or minus the square root of 75. We can simplify this by saying x is equal to plus or minus the square root of 25 times the square root of 3. So your final solutions are plus or minus 5 root 3. And so we solved this equation, found irrational solutions. I call them irrational solutions because 3 is not a perfect square. We solved using the square root property. Notice I added 75 to the right first, and then I took the square root of both sides. Also notice that I did not forget the plus or minus symbol. Whenever you take the square root of both sides, don't forget the plus or minus symbol. Our next equation says 36x squared plus 25 is equal to 0. Now this is a sum of two perfect squares, and we know a sum of two perfect squares does not factor. And so what we're going to do is use the square root property, and what we want to do first is isolate the squared expression. So we want to get x squared all by itself. So we can get x squared by itself if we start by subtracting 25 from both sides. And then if we divide both sides by 36, we get negative 25 over 36. Now the squared expression is isolated, and it's now that I take the square root of both sides. Now that leads me to x is equal to plus or minus, now here we go, the square root of 25 is 5, the square root of 36 is 6, and the negative underneath the square root generates I. So it's plus or minus 5/6 I. Those are two imaginary or two complex conjugate solutions. This one says x minus 7 quantity squared is equal to 25. Now, we're going to use the square root property here because this squared expression, x minus 7 is being squared, this squared expression is already isolated. So it's like it's set up already for the square root property. So what I'm going to do is take the square root of both sides. So I'll take the square root of the left-hand side. Now the square root of something being squared is just going to give you the base. So x minus 7 is all you have. Don't forget, plus or minus 5. Now to solve for x, let's add 7 to the right-hand side. Now be careful here. When you add 7 to the right-hand side, make sure to put this plus 7 right in the front of the plus or minus symbol. So that way you get x is equal to 7 plus or minus 5. That is to say, x is 7 plus 5, or x is 7 minus 5. Okay? And so then your solutions are x is 12 or x is 2. These solutions are rational solutions. So notice that in the first example that I showed you, you got irrational solutions. The next example, you got complex conjugate solutions or imaginary solutions. And in this example, you got rational solutions. All right, we're now going to transition to how to solve an equation by the process of completing the square. I've given you these list of steps that I strongly encourage you to copy down for your notes. And for the rest of the lesson here, we're going to be solving equations by completing the square, and I'm going to follow this process, all right? So make sure you've copied this down. I'm going to go through it with you now. All right, let's check out this first equation that we're going to solve by completing the square. Now, the process first begins by making sure the leading coefficient is 1. Good news, in this first example that we're looking at, the leading coefficient is 1, so that's good. The second thing is we want to collect our variable terms, which are these two, on the same side while moving the constants, which is just this one, to the other side. So let's move this constant to the other side by adding 3 to both sides. Now when you add 3 to both sides, you have the following equation. X squared minus 12x is equal to positive 3. Now here comes the very important step of completing the square. Step number 3 said that we need to take half of, or find half of, the coefficient of the first degree term. Stop right there. This term is degree 2, this term is degree 1, and then a constant term is degree 0. So this is the first degree term. The coefficient of this first degree term is negative 12. We have to take or find half of negative 12. That's half of the coefficient of the first degree term. Half of negative 12, of course, is negative 6. We need to then square the result. So I have to square negative 6, make sure you use parentheses, and you get 36. This is the square. So what we're going to do is we're going to add this square to both sides of the equation. Adding 36 here and adding 36 there. As long as we add it to both sides, we're good. Now the next step is acknowledging that this is a perfect square trinomial, and all perfect square trinomials factor as the square of a binomial. So it'll factor as the square of a binomial. The right-hand side is 39. When you factor a perfect square trinomial like this, first of all, our variable is x, so I'll write down an x. The next thing I'll do is, this middle term is negative, so I'll bring down this sign right here, all right? The middle sign is negative, so I put a negative. And right here, what I'm going to do is write down the number whose square gives me 36. Well, that's 6. 6 squared is 36, so I'll put a 6 there. And that's how factoring that perfect square trinomial works every single time. All right, so what we're going to do now is use the square root property to solve this equation. All right, so this looks awfully similar to one of the examples that we looked at earlier. I think it was example number 4, if my memory serves me correctly. So square root this side, square root that side. And then what you're left with on the left is just x minus 6. On the right is plus or minus, don't forget the plus or minus symbol, the square root of 39. To finish this, all you need to do is add 6 to this right-hand side, Now, don't forget that when you add 6 over here, put that plus 6 right here in front of the plus or minus symbol. So your final solutions are positive 6 plus or minus the square root of 39. These are two solutions, by the way. We're using double sign notation to say that one of the solutions is 6 plus root 39, and the other one is 6 minus root 39. Now, these are irrational solutions because 39 is not a perfect square. Next equation here, we have 3a squared plus 2a minus 1 equal to 0. All right, first things first, we have to make sure that if we're going to solve by completing the square, that the leading coefficient is 1. This time around, the leading coefficient is not 1, it's 3. We need this coefficient to be 1. So what we're going to do is we're going to divide every single term on both sides of the equation by 3. And that will give us an equation, an equivalent equation, whose leading coefficient is now 1. All right, the next thing we're going to do is we're going to collect our variable terms on the left side. So keep these right here, but this constant term, let's add it to the other side. Now that the leading coefficient is 1 and the variable terms are isolated, I am now ready to complete the square. I take half of the coefficient of the first degree term, half of 2/3, that is. Remember, this is the first degree term and the coefficient is 2/3. Half of 2/3 is just 1/3. Don't forget, we need to square the result. 1/3 squared, which means 1/3 times 1/3, is 1/9. So this is the square that you're adding to both sides of the equation. All right, so I've added 1/9 to both sides. This now is a perfect square trinomial, so we will factor it. On the right, I need some common denominators here in order to add these two fractions. The LCD is 9, so you don't have to manipulate the second fraction, but the first fraction, you need to rewrite 1/3, whose denominator is 9. Now let me show you how you factor this fairly easily. First of all, a perfect square trinomial always factors as the square of a binomial. The variable that you have here that you're solving for is a. I'll take the sign of the middle term, which is plus, and put a plus here. And then to finish this off, I have to put a number here such that when I square this number, I get 1/9. Well, that's 1/3. That's what we had said just actually a little while ago. 1/3 squared gives you 1/9. So that's the number that goes there. Now, for over here, I need 1/3 to be a fraction whose denominator is 9. Allow me to go over here just for a second, everybody. If you have 1/3, right, and you want it to be a fraction whose denominator is 9, well, you're going to have to multiply 3 by 3 in order to get 9. And whatever you multiply the denominator by, you're going to have to multiply the numerator by that as well. So therefore, 1/3 written as a fraction whose denominator is 9 is 3/9. So now I can add these two fractions. Let me move this screen up a little bit here. And so now we have a plus 1/3 quantity squared is equal to 4/9. This is the point at which you use a square root property to solve this equation. Now, on the left, you're just left with a plus 1/3. And on the right, remember plus or minus, and the square root of 4 is 2. The square root of 9 is 3. It's now time to subtract 1/3 from both sides so that we can isolate a. Now, don't forget, when you subtract 1/3 from both sides, put negative 1/3 in front of the plus or minus symbol. This will give you a is equal to negative 1/3 plus or minus 2/3. This means a is equal to negative 1/3 plus 2/3, or a is equal to negative 1/3 minus 2/3. So either your solution is positive 1/3 or negative 3/3, which is negative 1. And these two solutions here are rational solutions, two rational solutions. All right, a brand new equation to consider. Let's go through the steps. Now, I invite you to pause this lesson and to try this on your own first. And let's see if you and I can get our work to agree. The first thing I'm going to do is divide every single term by 2. The reason why I'm dividing by 2 is because I need the leading coefficient to be 1. Now my leading coefficient is 1. The next thing I'll do is move the constant term to the right. And I'll move the constant term to the right by subtracting it. So now I have negative 3/2 over there. Now it's time to complete the square. We find half of the coefficient of the first degree term, not the original first degree term, this one here, okay? So half of negative 6, which we know to be negative 3. Take negative 3 now and square it, and you get positive 9. 9 is the number that you're adding to both sides of your equation. Add it there, and add it there. Now the left-hand side is a perfect square trinomial, so you're going to write it as the square of a binomial. You're solving for x. The sign on the middle term is negative, so we'll bring down that sign. And you would have to square 3 in order to get 9. Okay? Now on the right-hand side, watch this. Allow me to kind of bring your attention over here just for a minute, okay? You have negative 3/2 plus 9. Negative 3/2 plus 9. Now, don't forget that 9 really has a 1 as the denominator. 9 is the same thing as 9 over 1. Now, the LCD for these two fractions is 2. So then you need this number 9 to be rewritten as a fraction whose denominator is 2. Well, you would have to multiply 1 by 2 in order to get 2. That means you're going to have to multiply the numerator by 2 as well. So 9 as a fraction whose denominator is 2 is 18/2. So over here, I'm going to write negative 3/2 plus 18/2. This leads to 15/2 on the right. Now we take the square root of both sides, okay? The left-hand side is just x minus 3. The right-hand side is plus or minus the square root of 15/2. Now, by the quotient rule for radicals, we know that this is equivalent to the square root of 15 over the square root of 2. What we'll do now is add 3 to the right-hand side. Now remember, you're adding 3 right in front of the plus or minus symbol. So now you have x is equal to 3 plus or minus the square root of 15 over the square root of 2. Now, someone may think you're done, but actually you're not done because this is not simplified. We learned in chapter 9 that we need to rationalize this answer. meaning we need to rewrite this so that there is no radical in the denominator. I can get rid of that square root if I multiply the denominator and the numerator really by the square root of 2, because then you will have 3 plus or minus, this would be the square root of 30, that's 15 times 2, and then the square root of 2 times the square root of 2 is just the square root of 4, which is 2, no radical. So now this has been simplified. Now, ladies and gentlemen, I can actually rewrite this and simplify this even more. 3 is the same as or equivalent as 6 over 2, is it not? 6 divided by 2 is 3. And so I just finished right now rewriting 3 as a fraction whose denominator is 2. Why did I do that? So that I can rewrite this as 6 plus or minus root 30 all over 2. Okay? So these are irrational solutions because 30 is not a perfect square. All right, this will be the last numbered example for this section, but there'll be two different equations under the heading example 10. The first one is here on the screen, x squared minus 4x plus 54 is equal to 0. Now, if we're going to solve by completing the square, we have to make sure the leading coefficient is 1. Well, the great news is that the leading coefficient already is 1. So all we have to do here before we complete the square is send 54 over to the other side using subtraction. So this will be rewritten as x squared minus 4x is equal to negative 54. Now that the leading coefficient is 1 and the variable terms have been isolated, now we can complete the square. I take half of negative 4, which is negative 2, and then I square negative 2, which is 4. So 4 is the number that we're adding to both sides of our equation. Adding 4 to the left-hand side definitely makes this a perfect square trinomial. So then it factors as the square of a binomial. The variable you're solving for is x. Bring down a minus sign, and you would have to square the number 2 in order to get 4. All right, what we can do now here is take the square root of both sides. Now, the square root of the left just gives you x minus 2. On the right, you're going to have plus or minus. Now, the square root of 50 will simplify as 5 root 2, okay? And then the negative underneath the square root will generate I. I'll put the I right here, okay, in front of the radical. The only thing that's left to do is add 2 to the right-hand side. Now remember where you're putting the 2, right in front of the plus or minus symbol. So then your final solutions are x is equal to positive 2 plus or minus 5I root 2. These are imaginary or complex conjugate solutions. Complex conjugate solutions. Now the last example here is x squared plus 2/7 x plus 2 is 0. Once again, I invite you to pause the lesson and to try this on your own. I think that would be good practice. All right, the leading coefficient is already 1, so what I'll do first is subtract 2 from both sides. When I subtract 2 from both sides, my variable terms are now isolated. I am now ready to to complete the square by taking half of 2/7. Half of 2/7 is just 1/7. And then I need to square 1/7. And I get 1 over 49. Don't forget that when you square 1/7, you get 1/49. Okay, that's going to come up in just a second. All right, so I'm going to add to both sides of my equation this square 1 over 49. All right, there we go. Now, the left-hand side is a perfect square trinomial. So here it is, the square of a binomial. The variable you're solving for is x. The sign on the middle term is positive. And then you need to rewrite, or you need to write the number right here whose square gives you 1/49. Well, we just said a little while ago, if you square 1/7, you'll get 1/49. So then 1/7 goes there. Now, as far as this right side, you need to rewrite -2 as a fraction whose denominator is 49. Let me see if I can show that down here for you. -2 is -2 over 1. And I need this to be rewritten as a fraction whose denominator is 49. And the reason why is because I want to add these two fractions, but I can't unless they have common denominators. So the question then is, what do you multiply the numerator and the denominator by in order to get 49 in the denominator? Well, 1 times 49 would work. So you're going to have to multiply the numerator as well. And 2 times 49 is 98. So -2 written as a fraction whose denominator is 49 is -98 over 49. All right, very good. So now I've added those two fractions, and now what I can do is take the square root of both sides. Square root of the left, square root of the right. The left-hand side is just x plus 1/7. And the right-hand side, well, the square root of 97 is just the square root of 97. The square root of 49 is 7. The negative underneath the square root gives you I. And then don't forget, because you took the square root of both sides, you need plus or minus. Now, to wrap this up, I will subtract 1/7 from both sides. So then you have x is equal to -1/7 plus or minus the square root of 97 over 7i. All right, everybody, and these are the solutions to our equation. These are two different solutions. They're complex conjugates, okay? -1/7 plus root 97 over 7i, and -1/7 minus root 97 over 7i. All right, that completes this lesson on the square root property and completing the square. This was a very important lesson. I trust you took very good notes. I'll catch you later.